Hello, and welcome to the Virtual Eclipse Community Meetup. I'm your host, Kat Hirsch, and I work for the Eclipse Foundation in Ottawa, Canada. We're now on to day 3 of the Eclipse Oxygen webinar series. So the 12th annual simultaneous release, Eclipse Oxygen, will ship on June 28th, 2017, and is full of great new features like the ones we're going to be discussing today. For more information, please visit eclipse.org/oxygen, and you'll get all of the details that we will be going through. So to become a member of the Virtual Eclipse Community Meetup, just follow the link in the description and you can find out what the plan is with this new webinar series that we're hoping to do twice a month. During the presentation, questions can be submitted throughout the presentation in real time, but we will reserve 5 minutes at the end of the presentation to discuss those with the presenters. And without further ado, I would now like to turn the stage over to Sven and Miro, who will take us through a presentation on New and Xtext, Core Framework, LSP, Tracing Code Generator, which will all become available on Eclipse Oxygen on June 28th. Over to you.
Thank you. Hi, everyone. Let me share the screen. And go over to the slides. So we are Sven and Miro. We work for Typefox.io or Typefox. Typefox.io is a website where you can see what we do. It's mostly we build tools and languages. We work on Xtext a lot, on language server protocol stuff and these things. Today, we want to present what is new in Xtext in Eclipse Oxygen. And in order to get there and find some motivation on why we did the stuff we did last year, I want to start with the history of Xtext. So at first, the first prototype of Xtext was created in 2006, which I did as part of Open Architecture.org, a code generation framework, which doesn't exist for a couple of years because all of the things that were there have been moved to Eclipse. One of which was Xtext that has been moved in May 2008 and basically re-implemented there. And the initial goal of Xtext really was to make modeling practical. That is, at those days, we were doing a lot of model-driven software development projects. That means we used code generation a lot in order to do software development. Which we still do, but maybe a bit different these days. At that point in time, a lot of people were using UML to define classes and attributes and relationships between them and so on, or other ways, and then get that information out of the tool they were using and fit them into a code generator. And that had a lot of problems because what we wanted to do is we want to build domain-specific languages. So just reusing a generic tool like UML just didn't fit the bill in terms of being domain-specific. And also, they were graphical and therefore not very practical. There were a lot of issues, like, for instance, with working in teams. So you would have these XMIs. This huge XMIs with all the UUIDs and so on, and when working in teams is really horrible then. So we thought textual domain-specific languages would make this more practical and efficient, and I think the success of Xtext proved us that it was really a good idea at that point in time. And so we also wanted to have tool support. So Xtext was really a way where you could have a grammar and some more additional configuration, and then you would have an Eclipse plugin, as well as a parser for the text, so you can feed it into a code generation, the model afterwards. So we were really focused on Eclipse during that time. We did so until roughly I think 2 years ago. And I think that was also okay because we were living mostly in the Java world, and in the Java world, Eclipse was very, very successful. So in 2011, it had a market share of 65%. But that declined a bit in the following years. So in 2014, it was only 48%. In 2016, IntelliJ IDEA even caught up to Eclipse. So the recent developments were really like Eclipse lost a bit of market share, even in the Java developer tool space, and others caught up. So we saw a lot of teams that were using other IDEs than Eclipse. And in addition, there was this trend of cloud IDEs and web-based IDEs that was very interesting. And because Xtext is used for domain-specific languages, which is not only for developers, but also for other smart people, we wanted to integrate the DSL editors in other applications, like web applications and so on. So that's why 2 or 3 years ago, we started making not only the core parts, like the parser and the validator stuff, Eclipse independent, but also some of the tool things like Content Assist and so on. And at the same time, we started working on additional support for additional platforms. Last year in May, we released Xtext 2.10. And then at that point in time, we had a very, very large repository with roughly 5 million lines of code. That includes a lot of unit tests as well. And of that, roughly 5 million were the core functionality, which is like the parser and validator stuff, but also the generic tool support we see and the testing we have there. But the rest was really like then specific to Eclipse or IntelliJ or so. At that point, also, we had a very complicated homegrown build infrastructure. We were using Buckminster, which is very Eclipse specific. And if you are familiar with Eclipse build or plugin development in Eclipse and having build tools there, you know it has never been easy. It kind of diverged now so that everyone uses Tycho. But if you also want to build, for instance, an IntelliJ IDEA plugin, they have their completely different architecture. And so, for instance, we use Gradle there and Tycho here and Buckminster as well and so on. So it was very, very complicated, and it's really, really hard to contribute to this. I mean, we had an oomph setup, but it's still you would be faced against all these complexity. So you had to deal with that. And in addition, there was some technical debt that came over the years. So we had one repository, and sometimes it was just easier to do a certain fix in the place where you would say, well, ideally it should be there, but then it's easier to put it here and so on. And because we hadn't this super strict separations, we had to clarify these things as well then. Around that time, I also came across a video. That's not the main reason, but I think it explains nicely why we went down this thing that we call Xtext Core. So this is Anders Heisberg, the designer of languages like Delphi, C#, TypeScript. And he, in one of his sessions, he said, over the last decade, we've become very accustomed to IDEs and powerful editors. And he mentioned that all of the functionality underneath the covers of these IDEs is powered by compilers. But he also said that these compilers are different than the compilers from the earlier days. And what he means by that is that usually a compiler has just the responsibility to get a bunch of files that are usually correct and translate them to some target bytecode, or even if you talk about transpilers, some target source code. But if you also want to use this compiler to support or to fuel an IDE, this compiler needs to deal with a lot of broken or mostly broken situations and files. and also with incremental changes, and it needs to be fast and so on. And so this is the reason why Eclipse has their own Java compiler, the JDT compiler, because the old Java-C was just not good for tools. And that's also why a lot of other tools than Eclipse use JDT. And so looking at that, Xtext actually also has this modern compiler architecture, simply because we always had Eclipse tool support in mind. So, I mean, the main thing in Xtext in the beginning was to provide this tool support. So we had incremental changes dealing with mostly broken files and so on. That was always on our agenda. And nowadays we have a runtime that is Eclipse independent or any tool independent, and it can handle incremental changes and so on. So we really wanted to reconsider the scope of Xtext to be a framework for these kind of modern compilers. So a solid library for modern language implementation at the core of a larger ecosystem. That also means like shrink it down a bit to what is really like the essential thing, the Xtext core stuff, and have separated a larger ecosystem that would come up with tool support for the different tools and so on, and other additional things. To realize that, we had to split the huge repository into several modules or parts. And that would help us to have different life cycles per project or module, as well as also allow different people to care only about those modules or that modules. So for instance, if you are interested in support, Xtext support for web stuff, you don't need to look at all the Eclipse tools, all the IntelliJ stuff and so on at all. You could even just run a Gradle build and that's all. And yeah, mentioning that, we wanted to have very simple standard builds. Standard means like a Java developer should look at the project and we don't want to explain a lot, because that it should be the standard way of how such a project would be built. And we use Gradle here. We could have used Maven, we just were happier with Gradle. And in the end, this splitting and simplification of the builds and so on should make it easier to consume Xtext as well as to contribute to it. So we split it up in these different repositories. And I will just quickly go through them so you have an idea. The Xtext core project is the one I talked about all the time here. This is really the platform independent, generic, modern language compiler toolset. Then that has dependency to Xtextlib. You can largely ignore that. It's very thin. It's a runtime library we use for Extend, the programming language we use internally in Xtext core. But then we have like split it out the Eclipse support for Xtext in its own repository, the IDEA support, as well as the web support. So they live all in their own repository and have a really like all the dependencies for Eclipse, web, or IDEA, they are there in those repositories. We also have Maven plugins that also live in their own repositories. The Xtext extras, they are tool independent, but they have additional complexity, or they target a narrower thing than Xtext core. So for instance, the Xbase language is there, the Java support, the eCore support, so these additional things. And then there is Extend, which is, I think, more like, yeah, it's easy to have it as part of Xtext because it needs to be released together with the rest, or especially the Xtext Eclipse stuff, because it uses a lot of internal APIs, and it's just easier to have it as part of the Xtext project. In perception, it's a separate project. All right. So the next part I want to talk about is the language server protocol, which, like the Xtext core project, in addition to be useful for having native integration for Eclipse or IDEA or so on, it also out of the box supports the language server protocol. The language server protocol is defined by Microsoft as part of the VS Code editor. And the idea is that an editor can connect to a smart modern compiler through a certain protocol that is standardized. And so in this protocol, you can send over messages and notifications, things like give me completions for this URI and this cursor offset, and so on. And Xtext implements this protocol, and by that, you can hook your Xtext language up with any editor that also supports this language server protocol. Last year at this time, that was mostly VS Code, but since then, the community has been very active implementing support for different editors. So today we have support in Eclipse.js, we have support in Orion. I'm not sure, it's not released yet, but they have been working on that. There is a plugin for Atom, for all the editors, mostly I would say. We are still waiting for one for IDEA. And also we at Typefox with others have been working on something called Thea that also supports the language server protocol, which we briefly show later. So this is a URL to the language, to the LSP. You can go there and see the whole protocol is defined in different versions. It's currently maintained by Microsoft, but they are open to pull requests and discussions there. How does it work? Basically, an editor, whenever it thinks it needs language support for, let's say, Java, it would start a process, a Java language server, and connect to it by sending it an initialize message, which tells the language server, hey, I'm an editor and I can do this and that. So sending the editor capabilities over, like I can do rename refactoring and so on. The language server then gives a response with also the language server's capabilities, like I can do this, but not that, and so on. And afterwards, the language server can be used. It's initialized on some root folder. The language server now needs to detect, okay, what is this? I'm sitting on a multi-Gradle project, for instance, and then it would look up the class path and so on. That is all language specific. Further, like you can open an editor, and then a did open notification is sent to the language server. Once you have opened an editor, then the editor is the one who owns kind of the content of this file. So the language server would no longer read from the file system at that point in time, but waits for change notifications from the editor. If you want to do code completion, for instance, then the editor would send a request to the completion. It sends over the offset and the URI, and the language server sends back a list of proposals. Also, if at any point in time the language server feels there are errors in one of the files it's watching, it can send over notifications for sending diagnostics. And then depending on the editor, these diagnostics are turned into markers or whatever. We've built something called LSP4j. It is a very thin Java library that can be used to translate between a Java API and JSON RPC messages. Basically, whenever you are in the Java process and you want to talk to the language server protocol, you can use LSP4j. It's Xtext independent. It is also used by the JDT language server or by the LSP4e plugin that is the generic LSP editor for Eclipse. Below, in LSP4j, below the language server interfaces and so on, there's a generic JSON RPC library that you can use for any kind of protocols and also to extend the language server protocol. With that, I'd like to go over to demo, show you Eclipse. So this is an almost Oxygen Eclipse. And you see a simple project where we have 2 files with a calc extension. And this icon says it can be opened in Eclipse's new generic editor. And the generic editor, there's another project I also already mentioned, is LSP4E, both of which will be presented on Wednesday and at the same time and in another Eclipse webinar. I just briefly want to show how these look with an X-Text language server. So I can open up this editor, and you see we have a domain-specific language that allows us to write arithmetic expressions and function calls, and also define functions.
Sorry, just a quick
and
interruption. We can't see your screen.
Oh, really?
Yes.
That's not good. Since when?
Just since you started switching over to the IDE to Eclipse. Right. Yep. So do you want to try to present your screen again? There we go.
Yeah, I did. Is it better?
Yep, now we can see it. Thank you.
Okay. Okay, so now you really see an Eclipse with 2 editors here, and I opened one of the editor of the text files in the generic editor, and which I mentioned is going to be presented on Wednesday. And this one is hooked up with an X-Text language server. So this DSL you see here has been implemented with X-Text, and it runs as a language server. And I can, for instance, hover here and I see the documentation. I could go to the definition. I can do find references if I go here. And you see it even, like, since it's the X-Text language server, always use the incremental project builder. It knows about the full project and indexes all the files that are in and gives you proposals, and also can give you the results of all the files. You don't need to open them or so. And for instance, I can go to the definition here. Yeah, of course, stuff like code completion as well works. And then there are even features that are not present in X-Text so far and in the Eclipse integration, but they are defined by the language server protocol, and then you can implement them based on the rich information you have in X-Text, like the AST and the parse trees and so on. One instance is a feature I really like is the signature help provider. And in this case, it's rather simple, but imagine, like, whenever in Java, for instance, you call a function, and the signature help provider will show you all possible overloads that exist, including the whole signature with the parameters and so on. And then it will also highlight the parameter you're currently working on. And that is really nice. You can also even have documentation per parameter. Right. So that's it for me. I hand over to Miro now.
Yeah, thank you, Sven. Sven already mentioned that one power of the language server protocol is to support many editors and IDEs with the same backend. And as another IDE supporting this, in addition to this Eclipse generic editor, I would like to present Thea. And so I'll switch to the web browser. So Thea is an IDE based on web technologies. In that regard, it is comparable to Visual Studio Code, for example. One main difference is that Visual Studio Code targets only standalone desktop applications, while Thea can be used both as a desktop app and also as a web application, like here. So here, currently, I have a web server running on my machine that serves this window here in my browser, and so this server also has a backend implemented in Node.js that does the file handling, so I can open files, modify and save them. And here again, I have an X-Text language server that is connected to that Node backend. So this is another DSL, but I get all the same kind of features that you're used to from Xtext, like here the cross references for content assist. I can navigate to the definitions and so on. And another very nice property of this IDE is that it's, in contrast, for example, to VS Code, it is designed for full extension, so you can really use it as a basis for rich client applications. So as one example for this, and also as an example of how the language server protocol can be extended, as Sven mentioned, I will show a diagram extension for this language. So I can open the same file with another view, which is generated automatically from the textual specification here in my text file. So now I get the text editor and and two graphical views that are synchronized to this editor. And I can navigate through this. So here I can zoom and pan. I can select single nodes. And you see the selection is synchronized between the three editors. If I select something here, the selection in the text is also updated, and the multi-core view shows which is the corresponding core on which the selected task is run. So this basically describes kind of a simulation run of a parallel algorithm on a multi-core processor. So this is a very nice. Shows very nicely that you can extend the language server protocol with another kind of protocol. This here we use an extension to transmit all information that is needed to display these diagrams here, and this is all done in the Xtext as part of an extension in the Xtext language server. Now we'll switch back to our keynote presentation. Okay, so all the examples that we are showing here are available on GitHub repositories. I think I will post the links also on the meetup page later on, or maybe tomorrow, so that you can check them out and try them. The README files should explain quite nicely how you can try it yourself on your machine. So now that we have seen a bit of what has happened in general in Xtext over the last year, and Sven has explained also why. So we have made a very basic changes and restructurings, and we have seen a new focus on the language server protocol. And I would like to focus down a bit about something that is specifically new for the current release of Xtext 2.12, which has been released in May and is part of Eclipse Oxygen. And this is a new feature for generating traced code. So it's about adding trace information to a target code that you generate from your DSL. So what is that and why should it be useful? Well, this is the base feature that you need in order to support navigation and debugging for your DSL in any IDE that supports this. So, for example, if your target language that you generate is Java, you really would need these features to navigate and debug directly in your source rather than in the generated code. So this is something that is very common to all those who have already been using XBase as a language basis of Xtext to implement DSLs that interconnect with Java. So there it is. It has been supported for many years now out of the box. There you can really put breakpoints in your source and single step through your DSL source, and you can navigate very nicely through other between Java and XBase DSLs. And so now it is about how do we bring this into other Xtext-based languages. I would like to dive into some details about this using an example. So this is again available on the GitHub project. I already posted this on the meetup page. So let's have a quick look at the example language, because I will use this to show the new features and how you can add tracing to a code generator. So on the right in the blue box, you see this DSL is about defining classes with properties and operations. And on the left-hand side, you see the corresponding grammar definition. So you can write class declarations which have names and members. A member can be a property or an operation. Property has name and a type. An operation has a name, a parameter list, a type, and a defining expression. So now let's pretend we have already written a code generator for this DSL and want to extend that one to improve it by adding tracing information. This is a situation where I suppose some of you might be in. So this is an example code generator that uses the usual Xtext API. So those who have already been using it know, might recognize the file structure. So you have a method here that is called by Xtext whenever the builder runs. And here we are handed in a file system access, which is a layer over the file system that we can use very conveniently to generate output files. So the format that we're using to specify the output in this case is the extend rich string or extend template expression, also called. That is the part of text between the two pairs of three quotes, triple quotes. And this is a very nice format to implement code generators, by the way. If you don't know it yet, check out the extend language. And so now let's take this as a basis, and let's say we want to trace our whole source model against this output text. Then we can use that. We can use the new API and replace this call to generate file by generate traced file. Now you see the method call has turned into red, which means that this is now an extension method, which is provided by the new API. And we also handed in a second parameter, the model, which means now we want to trace this source model, so which is the root of the AST in this case, to the whole output file. Well, this is already a good start, but of course, in order to support debugging, we need more fine-grained tracing information. So let's dive into the generate header function that is invoked from this template. This one defines, again, a template to describe the output text for a given class declaration. Here, our output code is in C. So let's say we want to trace this whole class declaration to the text of this template, so to this whole snippet of C code. This can be done very nicely by adding an annotation to this method, traced, which is an active annotation, which you can see by the red color of it. This means that extend invokes some additional code when you add this annotation, so that your code generator is enhanced and adds tracing information that does exactly what we wanted in this case. So it traces the first parameter of this method, the class declaration, to the output text. And now let's get even more fine-grained and say we want to trace even some single properties of this class declaration, like the name. So the decal.name, like you see it in the struct definition line of the output C code. Let's say we want to trace that property. That can be done very easily by replacing .name by ._name, which is now again an extension method. And this time, this method is generated specifically for your meta model, for this example meta model. I would like to explain this a little bit more, what it means. So let's get back to the grammar definition of the class declaration, which has name and members. Xtext using EMF generates a meta model class from that with exactly these properties as we have stated in the grammar. And in addition, it also generates a factory class. This one is often used in standalone scenarios in order to create instances of this meta model class. So now all we have to do in order to get these property tracing methods _name, as we have seen before, is we we create a new class, let's call it MyDSL trace extensions, and add an annotation to it, trace accessors. This is, again, an active annotation, as you can see from the color. And we pass the generated factory class as a parameter to this active annotation. With this information, Extend will pick up your meta model using Java reflection and generate tracing methods for all properties that are present in your meta model. For example, for the name property of a class declaration. So now we can use this MyDSL trace extensions class in our code generator by injecting it as an extension method provider. You may have noticed that the result type of this generated _name method is not a string or a character sequence or something like that, but rather a generator node. And this leads me to another thing I would like to explain. In the new tracing API, we have an intermediate format that is we call the generator tree, which is built, for example, when we state our generator output using extend templates, as we have seen on the slides before. So usually you don't have to bother so much about it. But this data structure is very useful because it serves two purposes. One is obviously to collect the output that we want to write. And this is described by the leaves of the tree. So the leaves can contain text snippets and indentation information or new line characters and so on. In order to build the output, we just walk over the tree in correct order. And yeah, like for this example, we get this line of C code. And the second purpose of this data structure is to derive the tracing information. So some of the inner nodes of the tree may have references to source locations to which we would like to trace the content of those nodes. So while constructing the tree, we derive source locations from parts of our AST, like for e-objects or attributes of some e-objects. And we attach this location information to the data structure so that later on we can serialize that into some trace format. So this is about the theory of the new API. I would like to just show an example how you can use these data structures also directly. This is an example code from our language that we're using here that creates or that compiles expressions. So the first line here says, I want to trace the expression object that I got handed in, and this creates me a node for my generated data structure. And then I can append text to it. So I can append the type name that is used in the C code, then result variable name, an equal sign, receiver variable name, and so on. So this kind of writing output is very useful if you need fine-grained access to the output, which is mostly the case for expressions and statements and so on. So this is actually quite similar also in XBase itself, by the way. So now we have two different ways to create this generator tree. One, the template expressions of Extend, and also here directly. Let's see how this looks like in action. So here I have this same DSL running in an Eclipse instance. So this is the usual Eclipse editor, as it was always present for Xtext. And based on the tracing information that I have for this source file, I can now right-click somewhere in my DSL. This is a feature that is always present if you use your DSLs in Eclipse. And I can select Open Generated File. In this case, now I have a dialog because from each source file, I generate two files, a header C file and a C implementation file. So I have to select which one I want to see. Go to the implementation file. And this now directs me not only to the file from which that has been generated from my source, but also the editor selects exactly the region in the generated code that corresponds to what I have selected in my source. And I can also go the other way around. I can select some part of code here in the generated file, right-click and say open source file. And this directs me exactly to the source location from which that line of code has been generated. So as I said, these features are always present in Eclipse and are very useful in also for rich client applications and so on. There's another feature I want to show very quickly, which is you can debug your traces in a way. So trace files are written in a binary format directly in the same folder where you put your generated code. Usually you won't see that in the Project Explorer, so they're hidden from there, so you need the Navigator view for that. And you can open these trace files, and Xtext gives you a quite useful viewer for them, which you can use for debugging. So here you see the hierarchical structures of the traces, and below you see exactly which source regions, here shown on the right side, are mapped to which target regions here on the left. Like the region marked with the 1 here, which is the get cache operation, is mapped exactly to this region here, which is also has the index 1. So this is very nice whenever you have to go deeper into the result of your generator and debug it. Good. We haven't seen any debugging yet, and I would like to show this feature in a different setting. So not in Eclipse and not with this DSL and with C code, but rather with another DSL that is translated to JavaScript. And the good thing about JavaScript is that it can be debugged in almost any modern browser nowadays. So that's why here I chose a web integration of Xtext. So we have here a text editor that is backed by an Xtext server, which gives me code completion and error markers and so on. And I have a code generator that creates JavaScript code. And if I click on the Run button here, oh, I wanted to show this later on. If I click on the Run button, it executes the generated JavaScript code, and I see the result value in a message box. Okay, so now let's go back to what I had just closed here. So I open the developer tools of my web browser here, and I go to the sources, open the index.html, and I set a breakpoint exactly at the piece of code that executes my generated code. Then I go back to the web page, click the Run button, and then I see, okay, my breakpoint is active. And now I step into this execute function that is called here. So this is all just static code that is part of the web page itself. And now this calls the generated JavaScript code. And now you see the really cool part. The web browser in these Chrome developer tools displays not the generated JavaScript code, but it displays the source DSL code from which it was generated. And I can even step through it line by line, and Chrome displays the intermediate variable values. And as soon as this output statement here is executed, I see again this dialog with a result. So we can, if by examining the file structure of this project here, we can also see the generated code. So this is what our code generator has written for the given source. And we see here also a comment at the end of this file that points to some additional file, which is a so-called source map. And source maps are a standard format for JavaScript programming that allows to specify the mapping between source and target whenever JavaScript is your target format. So this is picked up by the web browser, in this case the Chrome developer tools, and used in order to give us this feature that I've just shown, to single step through the source code and to see the variable results here. I can show you that URL in my browser. And here we see this is a JSON file that contains the complete source code.
Sorry
embedded.
to interrupt. Miro, your screen's disappeared.
Okay. It still shows me
Let me try
that I'm
this.
sharing screen.
Can you try to disconnect the presenting and then just reshare your screen?
No?
Nope, still not seeing it. So
Strange. Okay. Maybe if I say stop sharing here. Is it better now?
No, we will see
no.
it.
No.
So if you disconnect the video and then press the screen share.
Yes,
No.
I've done that.
No, we still can't see it, unfortunately.
Strange. Yeah, I've done that. I disconnected and reconnected, but
Let me see if I can do anything on my end. Sorry for the technical difficulty. So let's see here. All right, so try.
still no luck. Well,
No.
anyway, this was the last thing that I wanted to show.
Okay.
So, but you have seen the debugging tools of the browser?
We can't see. All we can see is your icon.
So just the last thing you could see was it the debugging tools of the browser?
Yes, I believe so.
Okay, so that's the important part. So the last thing I wanted to show is going back to my browser page and just to show the JSON file that is generated as a source map. So, but you can try it also. Everyone can try it yourself by checking out that example. So, just wanted to show the source maps are a standard format. So we didn't invent that ourselves, but we just generated these JSON files from the information that we got from our Xtext code generator and the tracing information that is connected with that. So yeah, and the cool thing is also this kind of generating trace or JavaScript source maps is done very generically. So you can just have a look at the source code of the example and actually apply that to any kind of Xtext language that is translated to JavaScript. Good. Yeah, basically that's it from our side. We only had one slide left showing, again, the links to the demos, but as I said, we can add some links also on the Meetup page. So anything else from you, Sven?
No, I think we should give back to you, Kat.
Okay. Can you hear me?
Mm-hmm.
Okay, great.
Yes.
So sorry about that. I'm not really sure what the issue was with the camera, but what I'll suggest we do is if you can send us the 2 final slides, I'll upload them in the comments and I can add them to the video in case people missed that content. So we'll make sure to get that information to everyone who's watching. So we do have a few minutes now to go through questions and answers. So if there are any questions regarding the video, now is the time to submit them in the chat box on the right-hand side of the YouTube live event. A few other housekeeping topics just before we go through the questions. So the next Eclipse Oxygen webinar series will take place tomorrow, Tuesday, June 27th at 9 a.m. And the subject of the webinar will be What's New in Eclipse Platform. That will be with Lakshmi Shanmugam from IBM. And just another reminder to also join the meetup, join the Virtual Eclipse Community Meetup if you haven't already done so. We launched this approximately a month and a half ago, almost 2 months ago. We're up to 200 members. We're growing rapidly, and we want all of the content that we produce in these presentations to be driven by the community. So if you have ideas, if there are topics that you'd like to discuss, please send them to us. You can send them on the actual Virtual Eclipse Community Meetup page, or you can email marketing@eclipse.org. And I will check to see if we have any questions before we wrap up. So just bear with me one moment as I mute my mic. Okay, so there don't seem to be any other questions. So if you do watch this video and you have a question for Miro or Sven, again, the best way to reach them would be to send an email to marketing@eclipse.org. And we will add a number of links from the presentation to the comment section of this video. So be sure to subscribe to our channel, and we'll hopefully see you tomorrow. Thank you, Miro. Thank you, Sven.
Thanks for having us.
Thank you. Bye.
Bye.